Okay, so we're just going to do a straight up domain and range example of two continuous functions. Let's be honest, discrete functions, pretty easy for us to do domain and range on, just basically listing out those values. However, when we get to the continuous functions, that's where some things can get a little nasty, especially when we see kind of some complicated things like this. So we got two functions here. We got f of x, y is equal to f of x, and y is equal to a g of x here. You might be kind of wondering what on earth is this whole like y equals f of x deal and y equals g of x deal. This is 100% a pre-cal thing here, and we're really just saying that the y coordinates are a function of x, the y coordinates are a function of x. It's just another way to say y coordinates, and we're just describing that this is a function of x, and we're using two different variables for that. Wouldn't worry too much about this. Just know that they're describing the y coordinates, and that is this curve as you see it here, and this curve as you see it in B. So let's do A. We're going to do these both in interval and set notation. I'll talk a little bit about which one I like, and we'll continue from there. We will do domain first. Usually domain is the always one that's done first because it is about the independent variable. Let's be honest, everything's about x in math anyways. So we kind of do those things first. So let's do the domain first. Now, let's read this. First off, we have an arrowhead, and this arrowhead is pointing upwards, but it's also pointing to the left. It's going upwards, but it's also pointing over to the left. So this will continue to infinity, but it will continue leftward to a negative infinity for our x direction or for our independent variable, and it will travel up towards positive infinity for our range or our y coordinate or y values. So let's do domain, and let's do this in terms of our set notation first. So we're not doing perfect math, the perfect math notation where it's like x, such that, all that kind of stuff. We're just going to limit it and chop it down to just the essential stuff that we need to know. So we know that the absolute lowest value of x is negative infinity, but we can't put that in terms of our set notation. We don't have infinities in there. So we're going to start with x, and we know that x is going to be less than or equal to some maximum value. I hope we have some maximum value here. Let's keep on reading this graph from left to right. So we're at negative infinity. We're following our curve. We kind of cross this negative 2. I'm reading my values down below, by the way. So we kind of cross our negative 2. We keep on going. We hit negative 1. We go to 0. We go to 1. We go to 2. And it looks like we stop right here. It looks like our graph stops right here when x is equal to 3 and when y is equal to 8. So all of our x coordinates in this entire y is equal to f of x, our function, has to be less than or at very maximum equal to 3. And this would be our domain in set notation. Now if we're doing interval notation, then we can have our negative infinity in it, and we would have negative infinity all the way up to 3 inclusive. You can kind of see the similarities, but also, of course, the differences between these two. We got our braces for domain over here, and then we have our non-inclusive and inclusive brackets around negative infinity and 3 respectively. Let's turn our focus to look at the range now. So the range. We're not using x anymore, but we're using y. So our lowest value of y is right down here. That's negative 1. And we've already talked about how this graph, the absolute maximum value of it, is going to be positive infinity. We already talked about that. Even though that we have a y coordinate of 8, our absolute maximum, or I should say our absolute most rightward point is 3, 8. For range, we keep on going to infinity. So all of our y values have to be greater than or equal to negative 1. That would be our minimum. Now, if we do this in terms of our interval notation, then we're going to start with an inclusive bracket around negative 1, and then we're going to go to infinity with a non-inclusive bracket. So we're just kind of separating these two, but they do share those similarities. So that's kind of A for us. Let's go ahead and let's do B now. So for B, let's do domain first, and again, we'll do this in terms of set notation. Our absolute lowest value of x is -2. Our absolute highest value of x is +2, and we have all of these in between. So to say that, we start off with our lowest value, -2. We sandwich x in between it. So -2 is less than or equal to x. Another way to say this is x has to be greater than or equal to 2. But then we have to cap it off and say that x has to be lower than or less than or equal to +2. So in our set notation, we are not using infinity because there's no arrowheads on our problem. And we're indicating our domain by using our x value. We have -2 as our lowest, +2 as our highest, and we're using our inequality equal signs in between with braces around it. With interval, pretty easy. We just have to go to our lowest value with inclusive brackets, our highest value with inclusive brackets, and we are done our domain. Our range, very, very similar. Let's look at this. Our lowest y coordinate is 0. You can see that these coordinates are along the x-axis, which is the y is equal to 0 line, and they go up to a y coordinate of 2. 0 is less than or equal to y is less than equal to 2. If we're using interval notation, then we go from inclusive on 0, inclusive to 2. Largest is our right value, smallest is our left value. Same thing over here. We go from smallest to largest. Regardless if we're using set or interval notation, we have to follow that. So 2 kind of examples of domain and range. They're challenging examples. I love interval notation. It's clean, it's crisp, it's great, except it sucks later on when we get to something called NPVs. If you have any brothers and sisters in grade 11, perhaps even grade 12, these are like things that X can't be. And then it gets to be a little bit of a challenge to give domain and range. However, for right now, and even even in later courses, I love this interval notation just because it's really concise and it's clean. Good domain and range question, and well, that'll be it for this video.